If you want to really dig into the traffic and see what is happening on the network, you want to use a protocol analyzer. So what I'm going to do now is I'm going to give you some tips on how to best use things like Wireshark. Wireshark you can see in front of you, tcpdump, tshark, and iptables to monitor your network for security and privacy-based events. Wireshark is the free cross-platform GUI, really the gold standard for free analyzers, protocol analyzers for network traffic, and it is available for Mac OS X, Windows. It's truly cross-platform, and here you can see it in Kali. It is available in Kali. Tshark is the command line version of Wireshark, and this is also cross-platform, and you'll see that this is available in Kali as well. tcpdump is another command line protocol analyzer that is often available natively on Mac OS X and Linux systems, and it's included often on routers and or firewalls, sometimes embedded devices that we need it to be running on in order to do this network monitoring that we want to do. There is a Windows version, and that is called WinDump. So those are the main protocol analyzers that people tend to use, certainly the free ones anyway. So where do we run these protocol analyzers? Well, we can run them on the devices, on the network, on each of the devices. We can run it on the router and or firewall. But if you run the analyzer on your devices like your laptop, you will be limited in the traffic that you can see if you're using a switch. If you remember the isolated collision domains, these limit the traffic which you can see. Also, if you're concerned that you may have malware on this device and you're trying to run the protocol analyzer in order to analyze or determine if there is malware on there, it's not really advisable to do it on the same machine, because if it is low-level malware, it could potentially provide false information about what is traveling on the network, and it may just simply not allow you to do it. If you really want to see what is going in and out of the network, you need to run the analyzers on the router and or firewall, as this is the hub of the network. Everything goes through it. Also, any malware or rootkit that is on here that is hiding traffic from your device cannot hide it from here, because the traffic has to go on the network if it is on the network. So let's talk through some of the ways of using the protocol analyzers. If you're not concerned about malware on a device and you want to see the traffic for that device, you can run these tools locally on the device. Mac, Windows, Linux can all have Wireshark very easily installed on them, so it's easy just to run Wireshark on these and look at the traffic that that device is sending and receiving. But here we're interested more in network monitoring to really see what's happening on the network. One way to potentially see the traffic on the network is to use the functionality that comes with the router and or firewall in its GUI. If you have custom firmware or a custom firewall like pfSense, there may be functionality in the GUI that allows you to inspect traffic. So that's an option depending on what devices you have and what you need to do, how deep you need to look into the traffic. So you may not even need a protocol analyzer. If the GUI of the router or firewall doesn't provide what you need, then you can try to SSH into the router and or firewall and run tcpdump. tcpdump is actually on many routers and firewalls natively, which is nice. DDWRT and pfSense, for example, has tcpdump natively. tcpdump will take a little time to master, but if you use this cheat sheet, you should find it fairly easy to use. And I'll give you some tips now on how to find the sort of information you might be looking for. First thing we want to determine is what interface do we actually want to monitor. And we can look at what interfaces are available by running this command here. tcpdump -D. And you can see here I'm on a router, so there's actually quite a lot of interfaces. I've got my PPP0, which is my internet connection, my modem, I've got VLANs, I've got multiple wireless networks, I've got multiple Ethernet networks because it's a switch, and I've got the local loopback adapter. So I can just do a general traffic snooping on ETH0, which is one of the ports. -I is to select the interface, and ETH0 is obviously the interface. And there we go, it's as simple as that. So, and then it starts to capture the traffic, as you can see there. And there is a line indicating a connection from this IP address to this IP address here. But maybe you're not sure what interface you want to monitor, or you want to monitor all of them. You can try this. Use any, and then you simply monitor the whole network. And there we can see the traffic going by. We can display IP addresses and port numbers instead of domain names and names if we change and add the -N switch in here. And then we can see we're getting this .22, which is SSH. And we're also getting the port here. So this is communicating 192.168.1.1 on SSH to this device here. And that's essentially my connection now doing this. Maybe we want to see if anyone's using port 80 or HTTP traffic. DST, destination, port 80. Nobody's currently using it at the moment. Let's see if we can force it. And there we go, some web traffic. Maybe because it's web traffic, we don't want to show the numbers. And there we go, instead of the numbers, we've got the domain names that are being connected to here and on port 80. We could look at DNS. That'll be a good indicator as to what people are actually connecting to. So if we change this to port 53, we could remove destination and just have it port 53 on destination or source. And let's force something. So www.bbc1, which will be not available. But we will be able to see a DNS query. And there we can see it here. This is the DNS server that I've set it up to use for this demonstration. And that would be useful if you're using a VPN and you're wanting to make sure that there was no DNS leaks. And also to confirm that all your devices are sending DNS to where it is you're wanting them to send it to. As we're on the topic of VPN leaks, we can set this interface to the modem interface, PPP0, change the output to verbose, and look for IPv6 traffic. IPv6 can sometimes be leaked when you're using a VPN, so we could check to see if any IPv6 is going out over the internet from our network. And we can see here that there is no IPv6 going out. Maybe we want to look at all web traffic, so let's add in the other ports. So then we'd have or port 80 or port 443. tcpdump -i any port 53 or port 80 or port 443. You can see it's actually a fairly simple syntax. And there we go. You can see the internet traffic on the network. Now maybe we want to get a little bit more specific now in terms of hosts, who's connecting, who's not connecting. So let's lock it down to certain IP addresses. So what we're doing here is we're looking on all interfaces and we're looking for host 192.168.1.81. This is an internal server on this network, and we're not interested in any traffic that goes to that internal server from the local network. This is a local network for this test machine 1.0/24. So what this is going to give us, this is going to tell us if anything is connecting from external to this internal device, or simply anything that is not part of the internal network. And there we go, as expected, there is nothing. So that could show you, for example, if you're suspicious that there is malware on a device, you could leave that running and you would see if anything actually did connect into it. And this, instead of looking for just things connecting to .81, this is going to look for anything connecting to the whole network that isn't coming from the internal network. And there you go, you can see some TeamViewer inbound connections, which is not a surprise. TeamViewer uses a reverse connection in order to connect in. Instead of doing live capture, we can capture the traffic to a file for later analysis, and we can bring it into Wireshark to do that. The size of the file could be limited if your router only has a small amount of storage, and it is likely to only have a small amount of storage. So be very careful not to denial of service your own router by running this. But that is a possibility to capture to a file if you have the storage capability. I will show you a better way of doing this so that you can store the file remotely in a minute. And just to clear up what this actually means, the -s, older versions of tcpdump truncate packets to 68 or 96 bytes. If this is the case of the version that you are using, use -s to capture full-size packets if you want to capture full-size packets, if you want to look at everything that's going through. But of course, this will create a large file, and the -w means to write to a file. So that's given you a little overview of tcpdump and using it on your router and or firewall. As you can see, if it's on your router or firewall, you can get a good idea of what is going on your network by simply using that command line tool. Check out this cheat sheet here, which will get you to grips with its syntax. And unlikely to be on routers or firewalls, there is tshark. The capture commands are the same as with tcpdump, but it supports more protocol decoding. Tshark is only available if Wireshark is installed in most cases.